Wow. After the depressing lesson about when things go wrong with software, let's look at a case where things seem to be going right. This would be Bitcoin. The paper on which this is based is available, no surprises, at www.bitcoin.org. The paper was published in 2009 by Satoshi Nakamoto. Since no one has ever seen the author, it's not known if it's a single person or a group. Nevertheless, we'll proceed. The abstract of the paper is deceptively simple, but hugely rich in meaning. Here it is. A purely peer-to-peer version of an electronic cash would allow online payments to be sent directly from one party to another without going through a financial institution. Digital signatures provide part of the solution, but the main benefits are lost if a trusted third party is still required to prevent double spending. We propose a solution to the double spending problem using a peer-to-peer network. The network timestamps transactions by hashing them into an ongoing chain of hash-based proof of work, forming a record that cannot be changed without redoing that proof of work. The longest chain not only serves as proof of the sequence of events witnessed, but proof that it came from the largest pool of CPU power. As long as a majority of CPU power is controlled by nodes that are not cooperating to attack the network, they'll generate the longest chain and outpace attackers. The network itself requires minimal structure. Messages are broadcast on a best effort basis, and nodes can leave and rejoin the network at will, accepting the longest proof of work chain as proof of what happened while they were gone. That was the abstract. Each of these sentences is exceedingly important. Let's take this abstract apart sentence by sentence. One thing you'll notice is that a lot of ancillary knowledge is needed to paint the picture. This is not at all atypical of secure software. Quote, a purely peer-to-peer version of electronic cash would allow online payments to be sent directly from one party to another without going through a financial institution. Unquote. The notions that the system is peer-to-peer and that there is not a central financial institution are critical to the successes of the system. Having no particular middleman means that no one entity is in charge of the system. This has economic as well as security implications. First of all, Bitcoin is what we would call a fiat currency. It is money because people agree that it's money. This stands in contrast to commodity-based money, which derives its value from some commodity, gold, for example. In a situation where you have fiat money, you need a central bank which can regulate the money supply and generally defend the value of the money. Money supply is related to economic growth. Growth requires a growth in money supply. If the money supply grows too quickly, runaway inflation can occur. In the United States, the Federal Reserve is the central bank, and it regulates the money supply by setting interest rates. Bitcoin, however, is a fiat money and expressly without a central bank. The parameters for the growth of Bitcoin money supply have to be pre-programmed into it. So in place of a central bank, there's simply an algorithm. The Bitcoin money supply is purely the product of Bitcoin miners. We'll explain in detail what miners do a little bit later. But for now, they spend computational power on securing the blockchain or the public shared ledger of Bitcoin transactions, and they are paid in Bitcoins. Initially, Bitcoin miners were paid 50 Bitcoins for creating a new block. In the current blockchain, every 10 years or so, the amount is halved. And it's currently at 12.5 Bitcoins as of July 9th, 2016. After a while, it'll be 6.25 Bitcoins, and so forth. This number converges at roughly 21 million Bitcoins in circulation. This means that after a point, the money supply won't grow and won't be able on its own to support an economy. It is possible that the programmed obsolescence of the money will give rise to another version of Bitcoin, which, learning from history, will be longer lived. For the moment, what's important is that the functions of the central bank have to be programmed into Bitcoin. This makes them transparent and unchangeable by a third party. Another part that first sentence talks about is money going from one person to another. Effectively, this is true, although nothing would happen without the work of a Bitcoin miner. Miners are independent, competitive groups of computing power. Most of the computing effort goes into finding a nonce, a 256-bit value, which when hashed with another 256-bit value produces a 256-bit value with 61 leading zeros. Because of the strength of the hashing algorithm, no analytical solution is known. It must be found by trial and error. The miner who finds this value receives 12.5 Bitcoins, at the moment about $12,500 for the effort. About 5 years ago, it was possible to use computer graphics cards for small custom-designed processors to perform Bitcoin mining operations. An individual could buy a high-performance desktop machine, the appropriate extra hardware and software, and hope within a year or so to pay off the investment by performing the mining operation. This is no longer true. Bitcoin mining operations executing hundreds of petahashes per second far outstrip an individual's capability. This has created a market for cooperative mining. An individual can join a mining group and work on a portion of that nonce finding problem. If the group is able to publish their block by finding the nonce before anybody else, the group is awarded the 12.5 Bitcoins, which are distributed among the group's participants according to the number of hashes that they computed. It's the independence of the mining operations, one from another, their competition for finding the nonce, that replaces the central bank's bookkeeping role. Once the block is secured and published, it becomes the head of the blockchain. If a transaction in that block rewards your Bitcoin wallet a few coins, then you get them, which is to say that you can use them or spend them. So the independent miners support the peer-to-peer nature of the system. The competition of the miners ensures their neutrality, thus removing that trusted third party. We'll break here and continue next time by looking at sentence 2 of the abstract. Thanks for your attention.